Alright, welcome everybody. Here, this video should be very short, but the way we express finding the derivative, that if we had some original function, let's say f of x, when we find its derivative, the notations we could use are f prime, or we could use this notation called d dx, or we can say we're finding the instantaneous rate of change. When you're finding the derivative of a function, you're calculating, just like we had in the previous video, right? What does the derivative of a function calculate? It calculates the slope at any given point. So here, if we wanted to find the derivative at this point of x for this graph, we're finding its instantaneous rate of change at that point. We're seeing how fast, let's say, some projectile is going at that point when we find the slope at that point. So here we have three different ways of expressing the derivative. So let's take a look at these questions here. They should be very short. Here it's saying, for the following, evaluate f prime of 2. Before we actually go through it, what do you think this question is asking you to do before I actually kind of explain it for you? Yeah? Take a second and just pause the video. What do you think you're going to be doing? Here, we're just going to first find f prime of x. So from the lesson we had before about the power rule, right, with that new little technique we have, what would be the derivative of this function? Right? It should be 12x to the 3 plus 10x. So this is the original function f. This is its derivative. Now, what is the question asking? It's saying, hey, find f prime of 2. So all we're going to do is plug in 2 into the derivative. So we just have f prime of 2 is equal to 12 times 2 to the 3 plus 10 times 2. And this becomes 12 times 8 plus 20, which is equal to 12 times 8 is what? 96 plus 20, and that's equal to 116. Okay? Remember, 2 to the 3 is 2 times 2 times 2, right? So 2 to the 3 is not 6. It'll be 8. Okay. So yeah, that's just the idea. It's saying, for the following, evaluate f prime of 2. So if we have f of x, we just first find its derivative and then plug in 2 into the derivative. Easy peasy. Let's look at the next question. Here it's saying, for the following, evaluate dy dx when x is equal to negative 5. And here, what I showed you previously, another way of stating that you want to find a derivative is taking d dx. So here, it's not to freak you guys out. What you're allowed to do is you say, hey, let me take d dx on both sides. So d dx on both sides. And basically what this becomes is we have dy dx is just equal to, so when you take the derivative of y with respect to x, we just have dy dx. Okay, so this means we're finding the derivative. And here we just follow our power rule. So don't freak out. So here we just take the power rule, so this becomes what? Find the derivative of this on your own, but it's just negative 15 x squared plus 4x plus 4. And now, this is dy dx. We're just taking the derivative. It's just another way of expressing it. And then here, it's just saying evaluate dy dx when x equals negative 5. So what are we going to do? We just plug in negative 5 in here. So that it becomes negative 15 times 5 squared plus 4 times negative 5. Oh, sorry, that's a negative 5. Plus 4. So then this becomes what? Negative 15 times 25 minus 20 plus 4. And whatever that is, I don't know, negative 15 times 25, whatever that is, minus 20 plus 4, that will be what we evaluate. Okay? What would that be? Negative 15 times 25, that's 250. 250 times, so that's what, negative 375? minus 20 plus 4. This is negative 390. 5 plus 4, negative 391. Hopefully my math is not wrong. Yeah. Okay. Here, for the next one, it's saying for the following equation, what is its instantaneous rate of change at x equals 2? So just like how we found the derivative for here, we found the derivative for here. Here, we're just finding its derivative. So we're just going to find f prime of x is equal to negative 4x minus, oh, this is just 0, right? So it's just negative 4x. And now we're just going to plug in 2. So we just have f prime of 2. So that becomes negative 4 times 2, which is negative 8. So the instantaneous rate of change for this function at 2 will be negative 8. So it should have some negative slope for the graph. Okay, that's it. Not that bad of a lesson. I hope you enjoyed the video. I'll see you for the next one.